Hey everyone, what we're going to do today is the elephant toothpaste experiment. And what we will need is dish soap, yeast, iodine, food coloring, and hydrogen peroxide, which I'm using 3%, so I'm going to vary the amount that I use instead of the concentration. Okay, for the first experiment, we're going to this bottle. And just drip by drip, just let it get in there. It's just the food coloring is just to give it a little color. I'm going to take the yeast. I'm going to go ahead and pour that in there as well. Not too much, but enough to get it really saturated in there. We're also going to put some dish soap as part of the mixture. I just want to cover it up. Let that move around in there. Now, add the hydrogen peroxide. You will start to see it bubble almost immediately. I'm going to stop right about there. Add just a little bit more because this is 3%, and watch it rise. This one is actually rising really slowly, and so by the time it gets up here, we'll be able to feel on the bottle a little bit, and the bottle is actually a little warm. It's not going to have the same heat output that you would with a higher concentration, but you can still feel the warmth of the bottle touching. A little bit more food coloring to give it a little bit more color, but there it goes. Elephant toothpaste for the first run of this experiment. For the second part, we're going to use all the same ingredients, except we're going to add the iodine, and we're going to add a little bit of extra hydrogen peroxide. So I'm going to go ahead and put the red food coloring in as well, kind of act as iodine in. And I just want to fill that base of that up so I know that it's covering it. And stir it around. You can see that it's already put a little bit more food coloring in this time to give it a little bit more color. Why did what happened? For the first go around, the yeast did did catalyze very well and went with the project very smoothly. Of course, without the higher concentration of iodine and saturated iodine, I had to use the whole bottle of tincture and much more hydrogen peroxide to get the second one going. And it is edited down a little bit because it was excruciatingly painful waiting for it to rise. But what was going on in the experiment, as far as what was actually happened, is what we were wanting to happen, and that is to create the foam bubbles. The hydrogen peroxide decomposes to produce oxygen, water, and energy. And then, of course, we had the other substances to give it color and flair. Iodine and yeast are both the catalyst, so they aren't actually involved in that decomposition. It just speeds the decomposition along. The enthalpy of the heat reaction is negative, and we know this not necessarily because we've measured it out and calculated it, but it gives off heat, so it is going to be exothermic. Exothermic reactions are going to release heat, and so we know that that change in heat is going to be negative. And as far as the free energy is concerned, we didn't necessarily take things out and measure them to be able to express through observation in this particular experiment what the free energy would mean, but it would be negative if we just utilized what we know from a basic formula standpoint. We can interpret from the literature of the equation that there will be a negative change in G. And so that means this will be a spontaneous reaction. So with the bubbles, why were there bubbles? Well, the medium of the dish soap wasn't necessarily involved in the decomposition. However, it gave it a medium for the air, the oxygen that was released, to create bubbles and create that foam, which you saw come up out of the bottle.